everyone. This is Dharmendra Reddy, MS, pursuing education in Sri Venkateshwar College of Engineering in Department of CSE AI. Let's explore the world of normal distribution. Normal distribution is a fundamental concept in statistics. It is the foundation upon which many statistical tools are built. Let us dive deeper and explore. Who invented normal distributions? Perry Simon Laplace is the first person is credited with developing the first version of the normal distribution in the early 19th century by studying errors in astronomical measurements. There is one more person who independently discovered the normal distribution, and that is Carl Friedrich Gauss. He is the only one independently discovered the normal distribution in 1809 while studying the errors of repeated measurements, who is the most often associated with its invention. Properties of normal distributions. Bell shape. Normal distributions are known for the distinctive bell shape. The curve is symmetrically and centered around its mean, with the highest point occurring at the mean. And mean and standard deviation. The mean and standard deviation completely describe a normal curve. The mean determines the center of the curve and the standard deviation determines the width. Empirical rule. 68% of the data falls within one standard deviation of the mean, 95% falls within two standard deviations, and 99.7% falls within three standard deviations. And asymptotic. Normal distribution extends to infinity, never touching the x-axis but getting arbitrarily close to it. The standard normal distribution. The standard normal distribution is a special case of the normal distribution with mean 0 and standard deviation 1. The distribution is important because it allows us to compare different normal distributions and perform some calculations more easily. The following section will explain the concepts of z-scores and how they relate to standard normal deviation. Let's see z-scores and probability calculations. What are z-scores? A z-score is the number of standard deviations that a data point is from the mean of its distribution. It can be positive or negative, depending on whether the data point is above or below the mean. Calculate the z-scores. Z equals to x minus mu by sigma, where mu is the mean of the distribution, sigma is the standard deviation of the distribution, and x is the data point in the question. And let's see how to use z-scores to find probabilities. By using standardized tables, we can find probabilities from z-scores. These tables tell us the proportion of observations that fall below any given z-square, as well as the area between two z-scores. Let's see how to use tables and find probabilities. Using the z table, we can find the probability that a random variable from the standard normal distribution will be between two values or lesser than or greater than a certain value. Let's see about z table. A standard normal distribution called as z table is a mathematical table for the various values of phi, which are the values of the cumulative distribution function of the normal distribution. This is how a z table looks like. And this is a table format. The rows of the table represent the one digit or the first digit after the decimal of the z-score, and the column represent the second digit after the decimal of the z-score. We have to find the number to find in z table, and we will find that number using this graph. And this is known as normal distribution or symmetric. This is normal distribution formulas. The probability density function f of x equals to 1 by sigma of root 2 pi e power minus x minus mu whole square by 2 sigma square. And the inverse normal distribution function is for a given area under the normal distribution curve, the inverse normal distribution function calculates the corresponding value of x. Let's see applications of normal distributions. Quality control. It is used in quality controls to identify and address problems. Stock market trading. It is used to understand stock market trends and how to make investment decisions. Medical testing. It is used to interpret medical test results, evaluate the accuracy of diagnostic tests, and assess the effectiveness of treatment. Psychology. Normal distribution is used to understand the distribution of IQ scores in populations and evaluate the efficiency of psychological treatments. For using normal distributions. Independence. Observations in the sample must be independent for each other. And random sampling. The sample must be selected randomly from the population. And normality. Data must be normally distributed. And equal variance. Variance in the population must be equal to homoscedasticity. Now let's discuss about limitations and alternatives. Limitations are only valid for continuous data, assume symmetric distribution, sensitive to outliers, may not work well with small sample sizes, requires assumption of normality, may not be suitable for non-linear relationships, and let's say about alternatives. Non-parametric statistics, bootstrapping, simulation-based methods, robust regression techniques, and generalized linear models, and machine learning algorithms as the effective in alternatives of normal distribution. Let's see calculating of z-scores. Find the mean and standard deviation. To calculate a z-score, you need to know the mean and standard deviation of the distribution from which the data come. Find the value of interest. You need to determine which value or values you made to transfer into a z-score. Apply the formula. The mathematical formula for calculating a z-score is z equals to x minus mu by sigma, where x is the value of interest, mu is the mean of the distribution, and sigma is the standard deviation of the distribution. Let's see real-world examples of normal distribution. Human height. Height in a population follows a normal distribution, with most people clustered around the mean and fewer people are at the extremes. And IQ scores. IQ score follows a normal distribution. Most people have scores around the mean of 100 and fewer people have scores at the extremes. And stock prices. The daily change in the stock prices are also tend to be followed by normal distribution. And now let's come to conclusion. Normal distribution plays a crucial role in statistics and is a powerful tool in many fields. By understanding the properties and applications of a normal distribution, you can make more informed decisions and draw more accurate conclusions. Thank you.